Okay. So, as usual, we are starting from here in the schedule, means today it's 22nd of May, right? So, we are here. I mean, we will finish discussing the authentication from the theory point of view, and then we will try to code a little bit, as usual, so that next week in the lab, Tuesday, you will try to implement it. It's mostly cut and paste, but there are a few things that we need to update in the application, okay? Like, saving the state of the fact that the user is authenticated, some information about the user, and the appearance of the application, what the user can do, cannot, and so on, okay? Things like this. By the way, my colleague, yes, will be present in the lab for next week. I will be in the last lab. Okay, so Antonio will be here at 27th, I will be in the last one. Okay, and he will give the lecture on the second part of Thursday next week as well. Okay, we changed the schedule a little bit, but the content is mostly the same. I mean. Okay, so, okay, if there are any questions, just feel free to ask. I published the solution for last Tuesday's lab, okay, so in case you want to have a look. As usual, it's just a proposal for a solution, okay? You might have implemented things in a different way, it's fine. Come to the lab, just ask, we are there. I mean, most of the time we are doing nothing, so, I mean, just ask us, I mean, and we are glad to help you and talk about anything related to the course. Okay, so, let's go back to the lecture. Yes, recording, right? Yes. So, you remember that on Monday we started talking about authentication. Authentication is different from authorization. Okay, authentication is showing who you are. Okay, typically using credential, username, and passwords. Okay, and we say that we implemented it with sessions. Sessions are characterized by a session ID, which is typically stored in a cookie for us in our web applications. That's the best solution that we can find. And there's some exchange between client and server when you start doing the authentication. You start from a page where you need to enter username and password, as we typically do on any websites nowadays, where you need to have a personalized experience. And then the server answers, in case everything is correct, with a cookie that the client stores. So the browser stores the cookie, automatically sends it to the server for any other request which belongs to the same domain and path. Okay, we say it. Okay, so it's basically handled automatically by the browser. In addition, we also say that, I mean, we don't even want the JavaScript to be able to access the cookie. Okay, because this is a security risk. Because if anybody managed to do some cross-site scripting attacks, so managed to introduce their code inside our application on the client side, can steal the cookie and so act as if it were authenticated. And we don't want this, of course. Okay, so in practice we said, well, you need to implement the login form, so just a form, username and password, send it to the server, answer with the response, yes or no. Very generic, no answer, no details. We don't want to give or leak any information. And this is just a normal form, as any form that we already implemented with React. So controller form component, 2 states, username and password is fine. And we say on the server side, we have a bit more work to do. On the server side, we need some frameworks to help us to handle the cookie and decode the information, checked for the password and so on. And we say the passport is the best solution at the moment for us that we are using Node plus JavaScript on the server. Okay. And we say that, well, username and password is handled by the local strategy, to which we need to pass a function where you need to give username and password, the one received from the client. And this will check if the username and password match with something that is already in the database. We also talked about the password. So we should store passwords in clear text, but we need to hash the passwords. Okay, so store something that cannot be cannot allow to reconstruct the password. Okay, so not just encrypting the password, but hashing the password. By the way, this is the reason why all well-constructed websites, when you need to change a password, say, well, set a new password, because actually they don't. I mean, when you forget the password, sorry, when you need to change, of course, it's fine. But when you forget the password, they cannot tell you the password. They don't know because they just store the hash. Okay, so they tell you just set a new password. So we'll compute a new hash. We'll store the new hash. Okay, good. We talked about the salt. Why using the salt? And we were mostly here, right? So salt is a mechanism to prevent people, attackers that have a long list of hashes to use brute force attacks, so trying to guess passwords, computing the hashes. When you have a list of millions, billions of passwords, so hashes, if you just do one computation and you can check against a billion values, it's much easier to find out something compared to the case in which you need a computation for each hack, for each password. And the salt is why is the way in which we prevent this type of brute force attack where you just compute the hash one time and check against all the passwords. Okay, because you need to include the hash in the salt in the hash as well. Okay, so you need to do more computations, which is computationally more expensive. Okay, but I mean, this is just the theory. We understood why we need the salt. And once we understood this, I mean, the way in which we represent information in the database is always the same, also for the exam and so on. So we will have an example where we have a table user, and so there will be the hash and the salt and user information as well. Okay, how can we implement this mechanism? Well, there's this script function, which is readily available in Node. Actually, it's in a module, but I mean, you don't have to install this module. It comes with Node. Okay, so you just need to do the require. That's fine. Okay, and sometimes it's a bit, let's say, inconvenient to use the code to generate your own hash because you want to set your own password and so on. So there are online tools, for instance. You can write your own code, it's fine, but I mean, there are online tools that can compute the hash for you, like PWD, it's fine. Put any salt you like, just type some random stuff that you will insert exactly as they are in the database in the salt column, okay? And that's the hash you should put in the database, okay? I'm telling you not to use this system because, I mean, we typically don't require to write the code to set up a new user, okay? Unless it's explicitly required for the exam. I mean, we expect the user to be already available and so already with the password in the database and just to be used, okay, for testing at the exam, okay? So either you write a lot of code to do everything from the web application, or you write a small piece of code to do the hashing manually, okay? Or you just use a system like this, okay? Since we are using this function as script, I mean, you just take the result according to the password that you want to set and the salt that you put in the database, okay? Good. Of course, I mean, from the security point of view, this is not the best thing to do. I mean, relying on external websites, you don't really know what's going on in that code and so on. I mean, typically these websites have a JavaScript code that does the computation for you. So typically it does the computation on the client side, but you never know, okay? But I mean, this is just to simplify things in the course. I mean, we don't want to spend a lot of time implementing the registration phase that we are not going to use it in the exam and test in the exam and so on, okay? I could give you the code to implement this stuff. You just need to do copy and paste, and so, I mean, it's useless to do these things. We try to focus more on the more important aspects, okay? The higher level aspects which have more value. Okay, good. So, the salt must be stored separately from the hash because we need to pass it to the script function separately as a separate parameter. Okay. So just use reasonable, let's say, values for the salt, not too short, not too long as well, it's fine. I mean, you will have an example, I mean, two examples, the one that we are going to do in the lectures, during the lecture, so today, and the one that we are going to publish in the solutions next week. Okay, and so there is a function actually to hash a password. That is the one we will not use because we said we don't implement the registration. And the one instead for comparing the stored password with the hash is useful, okay? And this one will be used in our code. Actually, again, just copy and paste because, I mean, checking the password is always the same procedure. But make sure you use functions designed specifically for this purpose. You see the name, okay? Timing safe equal. I mean, because there are many attacks that can be developed in this context. It takes less time to hash a shorter password than a longer password. You might be able to detect these things and so on. So, I mean, just use a function developed by experts in a good library and you are safe. Okay, so you don't leak information about what the password could be. Okay, and so password hash, actually, within password, I mean, code is mostly just to copy and paste, but just have a look. I mean, we get the user, I mean, we need to search for the user first in the database. Okay, we receive username and password. First thing we need to do on the server is check if the user exists. You never know, okay? Apart from mistypos, I mean, somebody could try to enter with some credentials, okay? So first of all, the user should be existing in the database, an existing user. So just a normal select, okay, from users table, okay, where email equal to, I mean, email is supposed to be the username, but it's not required to be an email. Often in the text for the exam, we don't say anything about this, but you know that most of the websites use emails. Why? Just because they are unique identifiers for users, I would say, around the world, so it's so easy, okay? The other typical identifier that you might use is the telephone number, okay? With the country code, it's unique in the world. But, I mean, the telephone number is a bit, more sensitive maybe as an information. So, I mean, the important thing about the user identifier is just that it needs to be unique, at least in the application, okay? Okay, once we discover that the email exists, so there's a row in the table where the email is set and equal to the one that we requested in the function, we just extract the rest of the information. So actually, the row password, you see, the row is the row that comes out from the database. Actually, password here means the hash, okay? So the column name is password. Maybe we could have said hash, password hash. Could be better for next year, okay? And then we need to compare it with the hashed password. Oh, I said one thing wrong before, right? I mean, it's up to us, not to the library. I thought the timing safe equal did something more, and it doesn't matter. I mean, we take the password coming from the user and we hash it by ourselves, okay? Sorry for the mistake. And then we compare it with the password coming from, actually not the password, the hash coming from the database, okay? And if everything is fine, just, this is a function accessing a database, so again, it returns a promise. We don't want to block the server in this operation, so just return a promise and then solve the promise when you finish your computation. So resolve, okay? If something goes wrong, reject. And then in the calling code, just have .n and do the things that correspond to the fact that everything went fine and catch, and you have the code for handling the error, okay? I mean, just copy and paste, not so difficult. Okay, good. And then we have to establish the session. Session means that we need to create this cookie. This cookie needs to go back and forth okay? Coming from the client, it's easy. Browser does everything automatically. Inserting it from the server side in the responses and so on, it's a bit more difficult. And again, we take some framework and library that helps us, and the name is has a lot of fantasy. I mean, Express sessions. It's a matter of Express, okay, more than Passport, because it's related to HTTP protocol, okay? The cookie is in the HTTP protocol, so you establish a session between different requests at the HTTP protocol level, okay? So it's a package, let's say, in the family of the Express packages. By default, it stores the sessions in memory. It's fine for us, okay? So also we restart the server, we reset the sessions and so on, so easy. But I mean, just keep in mind that for production, you should probably have sessions more persistent, okay? Not just because you restart the server, you make, let's say, 1 million users lose the authentication, and so you have 1 million users re-authenticating at the same time and so on, okay? But I mean, we are trying to focus on the server part just to understand the security issues, most of the security issues, and also because we need a server to make our client application work, okay? And so we'll try to give indication on how to implement things with Node, which might not be even the best solution in production in general, okay? You might want to use different systems like Java, like PHP, like whatever else framework you might think of. Okay, in short, just initialize it like this. The only thing you need to set is a secret. I mean, because it's just used internally to do some encryption or something. But I mean, we don't really care. The session ID that comes out doesn't contain any intelligible information, so you cannot read any clear text information in the session ID, and for us that's enough. Okay. 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 We need to set the secret. That's required, and we store is fine. It's a default value, and the rest, I mean, we don't really care. And then third element you need to care about when designing your code, and we will give a solution for this problem here during the lectures, and I think it's fine for any of your submissions, because I mean, just a way to attach some information to the session that was just created after the authentication. Okay, so there is you need to specify 2 functions and tell Passport to use 2 functions that basically decide the information that you want to store in the session. Okay, so there is a serialize and deserialize functions that you define in the form of callbacks that you pass to Passport that basically encode and decode information, okay, inside the session. It means they attach this information to the session on the server side. Okay, this information is kept on the server side in memory, as we said, and the typical information you want to attach to the session ID actually is at least who is the user that performed the authentication, as we said on Monday. Okay, so basically you need to call the callback that is passed in the function, okay? Basically giving an object, a JavaScript object that contains whatever you want to save in the session, okay? So the first element, I would say, it's the most important one. Without this, I mean, the session doesn't make sense because we cannot identify the user, okay? ID, user ID, typically the ID that you have in the database. You could even use the email, still fine, but it depends on what you think is the good identifier to be used in your application as unique ID on the server side, okay, and to associate it with the session. And okay, and then you have the inverse operation, okay. So when you receive an ID from the browser, so the session ID in the form of the cookie from the browser, Passport needs to retrieve all this information, okay, and make it available to you in JavaScript, okay, on the JavaScript that you run on the server side, okay. And actually, this is done, let's say, mostly automatically, in the sense that if you store the object is kept somewhere, and you can retrieve this object whenever needed. Okay, you could do something more complex, more interesting, like go in the database and do a further check, extract other information that is not in the session, in the memory associated with the session, and so on. But I mean, it's up to you to define these functions. In the example that we will give to you, probably everything is already done. Maybe you could have some cases, like for some exams, we ask like an admin user to be present instead of just normal user and so on. Probably you might want to add an additional property, like is an admin yes, no, or something like this, because it might be useful later for you for doing your operations. Okay, but I think you know, the ID and then additional information needed by the application, it's more than enough. Okay, so minimal content, we say that we need a user ID, a unique ID for the user. Yeah, actually we can go to the database and ask for information from the database corresponding to that ID. Still fine, okay? I mean, the difference is that in one case, it just the information is just provided to express when the session is established and kept in the memory and not further updated. And with this approach, you go to the database, and every time you receive a cookie, you go into the database, you retrieve the information you want to read. You want to associate with your ID. Okay, so it's up to you to decide which approach is the best for your case. From the practical point of view, in our examples, applications, it doesn't matter that much. Of course, the second solution requires more effort from the DB side, because every time you get an ID, you need to go to the database and extract some information. Okay, but I mean, the advantage of this approach is that if something has changed in the database, you retrieve the updated information. So up to you to decide what's the best thing. It doesn't make really a big difference from our small examples. Okay. Okay, and then I think that's the last. Last piece of information on the server side. What we need to do, we have routes. So APIs, we need to protect these APIs. We need to give answers to the clients only if they provide a valid session ID. How can we do this? Well, you know that between the name of the URL and the rest of the code that decides what to do and which answer should be sent back to the request, we can insert an arbitrary number of middlewares. Okay, and like we already inserted the express validator. Okay, it was an array with functions to be called and so on. That's a validator. It's fine. There's still room for the validator, but one thing we need to check is if there is oh, sorry, no, this is to create the session. Sorry. It's very similar to checking the session. Anyway, I mean, this is something to be executed before actually processing the request with our code. Okay, so in this case, it's just for creation of the session. Okay, so the first call we will do, and okay, and we call passport authenticate local. It means it will execute all the functions that establish the session. Okay, create the session ID, random session ID in the memory, send it back automatically without us writing anything here, okay, in the response. It's fine. Okay, this is the way in which we recommend to create the session. So a post operation, HTTP method requested to the server. I mean, the URL, it's up to you, but I think, I mean, over time, I think the clearest solution could be, you know, use like a session collection, okay? Think in terms of collection as we did for all the other APIs. So there will be a post API session, and this will create a session. There will be a delete API session. This will destroy the session, okay? And in short, nothing. Well, a get API session that will return some information about the user in case the user is already authenticated. So actually, I mean, it's very simple to decide, you know, to write something for the login. Just passport authenticate local and everything happens automatically. Why? Because this is a middle. This is something that is processed before this request, okay? This code, sorry. And so basically in this middleware, all the functions that we saw before will be called. So it goes to the database, search for the user ID. If everything is fine, it gets the hash, check the hashes, they match, it's fine, and it let the next callback to be executed. If something goes wrong, like the password don't match, for instance, it will return an answer by itself, and it will not call the next function in the chain, okay? So our function here, our callback will not be executed, and it will answer with something like 401 unauthorized, or something like this, okay? And it's up to us to decide you know, what to show to the user, okay? In the user, the user is interacting with the application, and the application should show something like incorrect username and password or something like this, okay? And so the application, the client will distinguish the two cases depending on the HTTP status code that is returned by this API, okay? Okay, good. Now we go back to the client. Let's assume we got some information after authentication. Authentication is a good time to return some information about the user being authenticated, okay? Like first name, last name, email, address, whatever you want. Depends, is it an administrator or not, and so on. Whatever is convenient for your application, okay? And so, as with any other API that returns information, you might want to store this information in a React state, okay? So, like you want to store the first name, last name, and so on. You store it into a state, you trigger an update of the React element tree, and it will show like, welcome, Enrico, or whatever, okay? Because you got the name of the user, okay? Because the user has logged in, so it has authenticated on the system. Okay, okay, there is a link. I mean, you can explore different solutions and so on, but we will see the code in a few minutes, okay? Okay, after the login, some routes in the server needs to be protected, as I was saying before. I mean, like, you want to have the list of all the items you purchased in the past. I mean, without authentication, it doesn't mean you cannot really return something meaningful because it's your purchases, not everybody's purchases, okay? Or like for the lab, you will have your own list of films, okay? After authentication, you get a list of films, but only your films, not all the films. That's a possibility, okay? Like you log in on the Politecnico website, you see all the exams that you passed, okay? But it's not just your exams, okay? I mean, there's a concept of exam, but this is what you passed, and somebody else might have a different list. And so this API needs to be first, well, of course, protected, but I mean, there are APIs that can return information, I mean, generic information, so protection is important if we want to give it only to authenticated user, but there are other APIs for which actually you need to know which is the user that has established the session because you need to return different information depending on which user has performed the authentication, as we were saying before in the example. So first, we need to provide a response only for authenticated users. Second, tell the correct information, because depending on the user, you might want to return different information. So how can we know that the user has been authenticated? Well, the browser automatically sends the cookie. Okay? Nothing to be done on the client side, except for telling the browser, well, please send the cookie. There will be just a row to add in the request, in the options of the fetch, because the fetch doesn't send the cookie by default. There is a slide about this. And then we will decide what to do. Remember, we have this CORS issue. This CORS, cross-origin request sharing, is a way to enable from the server side the possibility to read the responses coming from a different server on the client. Okay? And so we need to configure CORS correctly, and when we have authentication, it becomes a little bit more tricky. Okay? But I mean, once you do it for one solution, the rest is just copy and paste. Okay? So we need to change the CORS options that we pass on the server side, just to say that actually the origin allowed is not just everything. You remember the star, that was the default configuration. It cannot be star in case we need to handle cookie on the client, because it would not make sense. I mean, cookies should be sent only to servers that understand them, and the response should be used only in clients which have been, let's say, approved to work with the information that we provide from the server. So, in short, we cannot just write origin star. Okay, we need to be more specific. At least one origin. And for us, since we develop the client on HTTP localhost 5173, which is the White development server, that's the origin, HTTP localhost 5173. Okay, this is not the 3001. Okay, this is the server from which the CORS header is sent back to the client. And then we need to the second option as well, credentials true. Okay, just to say, I mean, we are allowed to get cookie information, and so please send the cookie information, which is important for us, and we can answer with the information related to the session. Okay, and the rest is the same. Just don't leave empty. This empty, so the parameter to the CORS call, but I mean just pass this object. Okay, so really simple, just two more lines. And on the client side, remember we need to modify all the fetch operations that request something on authenticated APIs using this object that is the usual object that says method post, method delete, and so on. It has a further property, credentials, and you need to put include here to say, well, please include a cookie if the cookie is present. So send it to the other site, website. So in our case, that's a localhost 3001. And so on the server side, we can establish which session you authenticated for, and then retrieve the information associated with the session and do all the rest of the operations. Okay? By the way, also the login request must include this option. I mean, just a requirement to make everything work smoothly. Okay, even if it's not a protected API, because it's the one from which we start. But I mean, that's the rule for the fetch. Protecting the server APIs. Well, Passport provides. I mean, the Passport local strategy provides a method suited for this purpose. So is .is authenticated. You just use it as a middleware, as the other ones. to be done at the beginning of a very callback. Well, you can put it into a body, okay, or you can transform it into a middleware, as we will do in a minute, okay. I mean, just a function that returns true or false, okay. True, okay, it's authenticated, so there will be another field where we can get the information about which user has been authenticated. And if it's false, of course, nobody has authenticated, so just handle the request in the correct way. Say, well, not authorized, or don't answer, or just answer with the public information, and so on, okay? So this code has to be inserted in many different APIs. I would say more than half of your APIs at the exam will be authenticated, because, I mean, we want a personalized experience, so we need the user to log in to see most of the content, interact with the content, okay? Might be there might be some public information, like the landing page, a list of stuff. I mean, that's very typical. I think you've seen some of the examples of the exam. I mean, from the past year, there are 4 exams already there. I mean, we didn't delete them. So, I mean, just examples to be inspired about what could come out, okay, for the exam. And so how do we write this express middleware? Writing an express middleware means just creating a function that takes 3 parameters: so request, response, and next, okay? And so actually the thing to be done is very simple. I mean, just call rec is authenticated. If true, just call next. So it goes on with the next middleware. Otherwise, you don't call anything. I mean, you don't call next, but you use res to return a response. Res status 400, 401, and then you're free to insert a body if you like, okay? So, I mean, any response can return a body. Typically you say, okay, not authenticated, or something like this, okay? You don't want to give away any other information. Just, you're not authenticated, you cannot answer anything. Okay, so you will see that most of the APIs that you developed, now we will include this middleware. So basically this function developed by you, and we will develop it into the code in the example. And just please don't forget to include this middleware when it's needed. So if the API is supposed to be authenticated, so you need to have a session established to request the information. Okay? Note that this is not enough. This is just the first part. Okay? So, first part is just answer not authorized if there is no session. But if a session exists, there are still many things to be done. So when a session exists, we need first retrieve which user is associated with the session, and then do only things that are allowed for that user and that session. Okay? So, in short, okay, let's say is logged in calls the next middleware. So we are back here in our code in the 3 dots, and we can process the request. But first, we need to know which user has authenticated before. So how do I retrieve the user? Okay. Well, you need to retrieve the user information on the server side. You cannot take it as information coming from the client. Everything coming from the client is untrusted. We cannot trust such information. There is a session established. There is information associated with the session. Just take the information associated to the session that is available on the server side. In such information that we saw before in the serialized, deserialized, and so on, if you didn't change the names, is available in rec.user. Okay? And this information is trusted, can be trusted, because it never leaves the server. It always stays in the server memory, and it's only manipulated by the code on the server. Okay, so it's not coming from the client. This is really, really important, and again, a major source of errors at the exam. Okay, so if we are not using this information, or we are just taking information coming from the client, it means that any user with any authenticated information can do operations on behalf of any other user. Okay? Because we can send anything from the client. We just stole a session ID using cross-site scripting, whatever you might be able to do. You stole a cookie that represents a session, you put in your browser, or also in an external client, you send a request towards the API. The API says there's an established session that is logged in before. Okay, so it proceeds and goes to the rest of the code, executing the rest of the code. And then it needs to decide which user has made the request. Okay? If it's important for the logic of the API, typically it is important, okay? Because we want to return different information depending on which user has been authenticated, okay? If just generic information, okay, we don't care, but in that case, we don't need the user information, so no problem about this. But when you need the user information, you need to take it from the information associated to the session on the server side. Okay, so I say it twice, even 3 times, because again, you need to be very careful and not to take this wrong. Okay, so sometimes I see at the exam, there's an API that takes in the body user ID, email, whatever. This is wrong because this information can be manipulated by the client that sends the request. Okay, you can only retrieve which user has been associated to the session that you are getting through the session ID, so through the cookie, by looking at what is the user associated to the session in the server. And in the code, it means accessing it through rec.user. Okay? Okay, good. Third point. Okay? No, this is the same. Okay. So any solution where the ID here that you're using, to check, to decide which is the ID of the user associated with the session, needs to come from the server. So if you're not using rec user, the solution is wrong. So it has a vulnerability problem. Anybody can set the ID. Okay, because you need to take the ID from some place, either from the sessions, fine, or from the client. Okay, the client is not supposed to send the ID here because it cannot be trusted on the server. So, and there is a session established, so it actually doesn't even need to send the ID. Okay, so when I see a solution, an API that has been designed to receive the ID from the client, the user ID, it's probably already wrong because you don't have any need to send this ID from the client to the server. That ID shouldn't be there, okay? Then maybe luckily you didn't use it, but it's probably wrong in the way you design the API. So you shouldn't send the ID if it's an authenticated API because the ID is already present in the session. Okay, and the second point which is in bold here, okay, sometimes you need to authorize operations on the basis of which user has been authenticated before, okay, and again, the information that you use to authorize the operation, also that information should come from a trusted source, okay. It means that, like, I can only delete my stuff. Okay, that's a typical situation in a web application. So I own my stuff. I delete my stuff, like my emails. Okay, each email has an associated owner. Okay, but I cannot get the information about which email I should delete. Okay, and not checking that the actual owner is me on the server. Okay, and which is the owner should be checked using reliable information. Okay, so I cannot say, okay, this is the ID of the email to be deleted, and just trust me, it's mine. I need to check that I have the permission to perform the operation. Okay, often it means just to check if there is an ID, user ID associated to that element in the DB, and so just go ahead with the operation. Okay, so like we have an example with the answers, questions and answers. Now today we will associate the owners to the answers. Okay, so I can only delete my answers. Okay, I cannot delete anybody else's answers. And the server should check that if I tell the server just delete answer number 7 before doing the operation, actually answer number 7 belongs to me. Okay, and it needs to check it, checking the information on in the server. Okay, in the database. Cannot just trust the fact that the application sent ID 7 because I could click only on my answers and not on anybody else's answer. Because the attacker is not using your application, it's not using your client, it's modifying your client, is using another client. Okay? So it's true that here, of course, the ID of the resource that I want to handle, delete, update, and so on, must come from the client. That's for sure. Okay? Because I clicked on number 7 or number 8 and number 9. This information needs to be transferred and sent from the client to the server. Otherwise, I don't know which one I should delete. But before doing the operation, check that you are allowed to do the operation. In more formal terms, you are authorized to do this operation. Okay? And to do this check, you need to rely on trusted information. Means something coming only from the server side where we trust the information. Just check in the DB if you can, if you are the owner, for instance, of the reservation, answer, field, and whatever. Okay? Otherwise, you risk that any authenticated user could send a request. It will pass the is logged in test. Yeah, not sure if, I think these brackets should not be present here, but anyway. Any authenticated user could send a request and pass this is logged in check. So you have any authenticated user as a session, okay? But that's not enough. You should check the user is authorized to perform the operation the user requests, okay? It's like anybody of us has an authenticated session with Google, okay? Because we have the email open in our browser, okay? But the server should check that I'm requested to delete the email with a certain ID, and actually that email belongs to me. So I cannot delete the email of somebody else. I know that, saying this in words is very easy to understand, but having it, writing it correctly in the code is not sometimes so easy. Okay, especially if you are running and submitting the final code for your solution. Okay, just remember this fact because this costs quite a lot of points. Okay, we are in the cybersecurity course of study. This is a very important concept to get here. Okay. Logout, so we're almost done, right? Yes. Logout, well, that's very simple. It's probably the simplest thing in all the passport framework. Just have a method logout, you call it, and that's all. Okay? It destroys the session ID and all the memory associated with the session, that session ID and so on. And you just need to decide which HTTP method works best, and we think the best solution, conceptually, is to have a delete method on API session as we had the post for creating a new session. Okay, we are deleting the session, it's fine. Okay, very trivial. And you don't have to send back anything, so .end is fine. If you like status 200.n, it's fine. I mean, JSON, something empty is fine. Okay, so just last set of slides. I mean, this last part. Just because we are not seeing any, let's say, mechanism specific for authorization apart from what I just said, so writing some code in the server part, okay? And sometimes, since we are talking about the web application, it's good that I introduce you to a few other mechanisms that can be used to handle authorizations in web application, okay? And this leads us to discuss a bit more about how can we handle operations after authentication, okay? One way is the way we require in this course, and also it was common until, let's say, 10 years ago or even more, and probably the only way. So establish a session with the server, and depending on the session, you decide on the server if you can do the operation or not, okay? And this is the so-called stateful server, what we saw until now. Stateful means the server needs to keep information about the session. Okay, if it forgets the information about the session, we lose the session information. I mean, the session information on the client becomes useless because the server doesn't recognize it anymore. And so we need to re-authenticate. Okay, it's like we deleted the cookie on the client, let's say. Okay, but on the server it's worse because even if you have the cookie, you cannot use it anymore. But there is another approach that is very, very much used in web applications nowadays. Actually, if you are curious to see more things about this, you can go to last year's course and have a look, okay, at tokens and so on. I will just say a few words, but I mean, we decided to change it for this year because, I mean, it's good to know, but then it's a bit difficult to, let's say, to try and use it for the exam and so on, because basically it's very useful when you have more than one server. Okay, we have one server, that's already enough. And this leads us to talk about the stateless servers. Okay, so actually the stateful server is what we have described until now. The server remembers the session ID and the information associated with the session. And every time it receives a request with the session ID, it decides if the associated user is authorized or not to perform some operations. Okay? But it does it remembering the session ID and potentially other information like the user ID and so on the server side. And this can be costly. Okay? Can cost quite a lot of resources. Of course, our applications are simple. I mean, it doesn't cost that much. But your Google, you have a billion of users logged in at any time. It means that you have a billion of sessions to manage. Okay, so any time you contact the Google server, it has to go through a table of a billion rows and search for your ID, and then take the information associated to the session and so on. Okay, so it can be costly. But yeah, with a single server, more or less it works. But we already say that when there are multiple servers, as it happens many times nowadays, it can become difficult to share information about the session between multiple servers. And that's why they invented this mechanism where there is a trusted entity, the so-called authentication server, that actually, instead of creating a session ID and storing the session ID, it creates, it creates a sequence of bytes which is actually a signed payload, okay? Which actually contains the information about what the user can do, who is it, and what the user can do, okay? And of course, we need to establish a format and so on, and we need to sign such information. If we sign such information, you don't need to go back to the original server, the authentication server, to check if that ID was authenticated at a certain point with that permission and so on, because what you have is signed by that server. And the only thing you need to do is to verify the signature, okay? And this sequence of bytes takes the name of token, okay? And actually, again, there's something that needs to be stored on the client side in the browser. Now it's a token, and I don't want to call it cookie because actually it's not set through the set cookie header of the HTTP protocol. Just a piece of information that is sent back from some APIs in the body of the response or in some other headers, not the cookie one, okay? This token stays in the memory of the client, so actually not in the cookie storage, it stays in the JavaScript memory, okay? And it is sent together with the request to other servers by the client, okay? So any other server will receive requests, will not receive a session ID because there's no session ID involved with the other servers because we decided not to use the session ID. But you need to add this signed token. So this signed payload that contains the information about who you are and what you can do, okay? And the only thing the other server has to do is to verify the signature. If it verifies the signature, everything is successful. It means that what is written in the payload is true, okay? And so it will execute the request if it complies with what is written in the token, okay? That has been signed. Okay, good. It's like, let's say, your identity card, right? You have your identity card that has been signed by some, by the, what's the name, the officer at the, I don't know, the Italian Ministry of, what's the name? I don't know the translation in English. Anyway, it's been signed by the Ministry of Internal Affairs, okay? And you have this token, you take it with you, any place you go, they just verify that this token, this card has been signed by the Ministry of Internal Affairs, okay? And so actually, they trust the fact that your picture corresponds to the picture they are seeing, so you are actually you, the one you claim to be. And so that's the same principle, okay? Of course, it can be made in analogic format, I mean, with actual signature, which is a bit difficult to verify, but nowadays you have the digital identity card. It actually has a digital signature, okay? And the ministry signs it only if it thinks that actually the picture and the information corresponds to the truth, okay? So it's actually true. And I mean, typically you just show it, but you can verify it digitally, okay? Because the public key of the ministry is available, okay? You just check if the signature is valid. If it's valid, you can trust it, okay? And that's actually the same thing that happens here on the any server. So you just authenticated once. You went to the office, municipality office. You went to the police for the passport and so on. You authenticated there. There was somebody in charge of authenticating you, looking at your face and the documents and so on. And he decided to sign the passport and the ID, okay? And then he gives it to you, and you go around with this ID, and this ID can be used anywhere they are able to verify it. So they can check the signature is valid. Okay, good. So this scheme works best when there are multiple servers which cannot easily share a session, okay? But can easily verify a signature. Okay, and actually these sort of schemes are very common, but also, you see, are very complex because it involves many servers and so on. So to experiment with these schemes, it means we need to have at least 2 servers, if not more, and we need to I have to have some meaningful information that is available on one server that couldn't be stored on the first one, and so on. And so it becomes a bit more difficult to experiment. So I just wanted to mention that establishing a session is not just the only way in which you can, let's say, prove that you can perform some operations on a server. Okay, there are different mechanisms based basically on these tokens. Okay. Standard token formats exist. Indeed, last year we were talking about the JWT, JSON Web Tokens. They have been standardized and so on. And there exist many standardized flows of authorization that provides you tokens that, let's say, allows you to access further resources, authorize you to do operations and so on. Okay. It's like more or less the Polito website. You know that the Polito website, actually I see the teacher's version, but I hope that also the student version works this way. I mean, you authenticate once, you get some information that is stored in your browser, and then you can access multiple services, like the email, like the information about your exams, some other sites that are available from the Politecnico requires authorization to perform operations and so on. And this is actually the same mechanism that you will see in other courses in the course of study of cybersecurity that allows you to, let's say, log in with the credentials of another website. Like there are websites that says, oh, you already have a Google account, that's fine. Okay, just enter actually username and password that you have on Google, but actually you're not sending your username and password to that website. You're sending it to Google. Google creates a sort of token that then can be used to, let's say, verify that you are the one that you claim to be on the other websites. Okay? So this flow of information is quite complex. There are different standards as well. And that will be discussed a little bit more in other courses in your course of study. Okay? Actually, tokens can also be used for identification purposes. I already told you about the example of the identity card or passport. Okay? Actually, that's another way of establishing a session, but I mean, we are not covering it here. If you're curious, I would say just come to the lab and we can discuss it. Okay? Not to be used in the school, just for simplicity. Okay, we would like you to stick to this example with the session ID and the authenticated session. We only have one server, and then you need to verify the possibility of performing the requested operations on the server side. Because, I mean, simply we think it's more, let's say, useful for you to understand who should authorize when and using which kind of information, coming from which source, and so on. Okay? So in short, let's say you need to pay a lot of attention to this aspect. That's actually the same example as before. Okay? Regardless of how you get the information about the user, authenticated user, okay? You always need to carefully check authorizations on the server side, okay? It's really important. You don't come at the exam, as many do, and say, well, actually, no, I didn't check it on the server because I already checked it on the client, okay? So it really means, I mean, the last part of, you didn't get anything about the last part of the course about authentication and authorization. Because anybody can come, okay? Anybody means anybody in the internet from the other side of the world can send requests, okay? Just because it has a session ID, it doesn't mean that it's authorized to do things. You need to check these things without trusting information coming from the client. Because the client can be anything, okay? Even for authorized users, okay? You are all authorized users when you use the Politecnico website, but you shouldn't be able to change your colleagues' votes and so on, okay? Or do request on his, her behalf, okay? And the only way in which you can prevent this condition is this one. Check in the database who is the owner of the information you want to access, you want to modify, and so on, okay? There should be some information, of course, on the server that says who, in terms of which user ID, can operate on such information. Without that, I mean, of course, you cannot check anything. But probably it's a wrong design in terms of the database. If you have it, you need to check such information and check it against the user associated with the session, not something coming from the client. And checking the authorization for some information, I mean, through some information coming from the server as well, okay? Okay, so, long story. I mean, really, I'm really insisting on this. You say you saw so many, you know, balloons, orange balloons, okay? Because really, this is something that we spend quite a lot of time at the exam. I know it's on the server side, not on the client side, but this course is supposed to give you an overview of how web application works, including server side, because you don't have a course dealing with server sides only, okay? So, and also we have focus on security, and there are so many vulnerable applications around. You have no idea. I mean, I've neither, but I've seen, you know, so many vulnerable applications because they think, I did a check on the client, so it's fine. The user cannot send a request. It's not about your user. Your users are fine. They will not send a request. It's the attackers that will send a request by modifying your application or just using another client, a command line client and so on. Just take the authenticated session, so the session ID, they steal just one session ID, and then they can do whatever they want, even if you checked for authentication. Okay? So just think a little bit about these things. I would say let's have an early break, okay? And yeah, 10 minutes, something like this. And then we will try to implement everything in an example, okay? As usual, it's already online. The authentication example, I just put it, I think yesterday evening or this morning, I don't remember. And so something is already there in server and client. We will finish the discussion implementing the client part. The server part is almost done, okay? But the server part is quite easy. It's, you know, copy and pasting. We can focus a little bit more on the authorization part. So the checks that need to be done on the server side to check that you actually act only on the data for which you have authorization, okay? Okay, no questions, right? So let's break for 10 minutes, a bit more. Okay.